Okay, so on to multiplying and dividing. Now, remember, when we're multiplying and dividing, that is different than adding and subtracting. The main important thing with adding and subtracting, guys, is we need to have a common denominator. That is not true for multiplying and dividing. And I'm just going to do a quick little work for the division because I don't really like students just memorizing flip and reciprocate and whatever else. So I want to explain that a little bit further. So I'm just going to do a basic fraction operations, explain it, and then I'll get to these problems. Do I have room? I do have a little room. I think we can use this space. So just again, regards, guys. Let's say we have 2/3 times, 3 over 4. Nah, not 3 over 4. I don't want to have simple ones. Let's do 4 over 5. Okay, so again, when we're multiplying here, we basically just multiply the numerator times numerator, which is 8, and denominator times denominator, which is 15. Okay, and then you always want to see if you can simplify. In this case, we can't. Now, if we have 2/3 divided by 4/5, nobody likes that many fractions, right? Half people don't even like fractions, right? So why are we dealing with so many fractions? So the main idea is let's just get this down to one fraction. So basically our goal is to see, so this is a different example, is let's get this denominator to 1. So we're only just dividing by 1, so therefore we're just dealing with the fraction here, right? Because anything divided by 1 is just, anything. Like 3 divided by 1 is just 3. So let's get this to be a 1. So then I got to think, well, 4/5 times what equals 1, right? And hopefully you remember that the reciprocal, right? That's what we call the multiplicative inverse. So if I multiply the denominator by 5/4, I have to multiply the numerator times 5/4. Okay, because you have to create equivalent fractions. And then what you see is this now produces the product of 2 over 3 times 5 over 4. So that is why we say, when you're dividing fractions, you flip and multiply. Well, again, it's, really just understanding that really what this gives us here is just the fraction divided by 1, okay? But that's why we're flipping and reciprocating with division. So anyways, in this case, I would get 10 over 12, which this I can simplify to, you can divide the top and bottom by 2, so that'd be 5 over 6. Okay, so that's with fractions. Let's get to the good stuff with rational expressions. So again, just like adding, subtracting, multiplying, and simplifying, or adding, subtracting, and just in general simplifying, the first thing we want to do is simplify. And wherever we have an opportunity to factor, simplify by factoring, that's what we're going to want to do. So here, again, I see a x squared minus 1. Now, the nice thing about multiplying here is, for instance, like I can rewrite just everything as a product. Like right now, this is multiplying, right? But even like 8 times 2 is a product. So I can really just kind of group everything together under one fraction. So I'll write it like this, 8 times x squared, and then over, let's see, what two numbers, that's going to be x plus 1. Oops, that's supposed to be a plus. X plus 1 times x plus 1, right? But remember, if you're multiplying here, then you can just write this as one fraction, x minus 1 times x plus 1 times 8x squared divided by 2x times x plus 1 times x plus 1. Okay, and now what we can see here is that the x plus 1s are going to divide out, and we're left with a x minus, I don't know why I'm using red, I'll use purple next. And what we can see here is we're left with a x minus 1 times an 8x squared divided by a 2x times x plus 1. Okay, and again, we're not going to worry about our, undefined values in the denominator, but you can see here by multiplying, you want to simplify, multiply, and then obviously look to simplify again. Notice that these two expressions are not exactly the same. I don't know why I didn't simplify my numbers and my variables, so let's go back to that because I just got lazy. Actually, I was thinking of something else in my head. Thankfully, I caught it. 2 divides into 4, so let's simplify this here. 8 over 4, right, 8 over 2, that can be reduced like our warm-up, right? Remember our warm-up, the 8 over 2, we can simplify this. So we could divide the top and the bottom by 2. Well, 2 divided by 2 is 1. 8 divided by 2 is 4. Another way to think about it is 2 divides into 8 4 times. Sometimes that's hard, though, because students don't know. Do I put the 4 in the numerator or 4 in the denominator? So hopefully if you see it in this in this fashion, you can see why the 4 is in the numerator. And then again, also, we see that x squared divided by x, you can see using the rules of exponents that we're going to have a 4x. So sorry about that. I caught myself right at the end. All right, so the next example, hopefully I explained very well why we flip and reciprocate. So then what that means is I am just going to factor this, and as I'm factoring, I am going to flip and change this to a product, okay? So here I need to factor this out. So again, this is going to be and again, you're only flipping the divisor, right? The fraction you're dividing, because that is what you're technically getting to 1. You're not flipping both fractions, which wouldn't make sense here, right? There's no sense to flip the 3/2. Why do we want that to be flipped? We only want this divisor to be flipped. All right, so let's see if we can figure this out without doing any crazy factoring. So I have a 2x and then times an x. And I need to get to a -5, but I need to add to give me a positive 10. So I see this being a positive 5 because 2x times 5 is 10. And then this being a -1 because -1 times x is a -1. So that's 10x minus 1x, which is 9x, okay? And again, we've been doing a lot of factoring practice in my class. Here, the difference of 2 squares, x minus 5 times x plus 5. Rewrite this as the product, meaning I'm going to flip this. Now, immediately, I'm going to rewrite this with a factored out. So I'm going to factor out a -1, and that's going to leave me with a x minus 5. And then in the denominator, I'm going to factor out a x here. So by factoring out an x, I'm going to be left with a 2x minus 1. All right, now comes the party of simplifying. So the simplifying party comes around and says, all right, whatever expressions are the same in the denominator and the numerator, we can go ahead and divide them out. And therefore, you can see everything divides out. We are just left with a negative symbol. So negative over x. But that doesn't really make any sense. What number here is attached? Well, you can say that that has a coefficient of 1. So my answer is really -1 over x, which is the same thing as 1 over -x, which is the same thing as a -1 over x. Okay, so just make sure you're understanding those different forms here. All right, and on to the last one. So let's pick blue. So again, we're going to do the same thing. I'm just going to factor these and then reciprocate and multiply the divisor. So you can see a difference of 2 squares in this case. Whew, making it fun. All right, so in this numerator here, I can factor out an x. Actually, let's do 2 steps here. Let's factor out what we have here. So, because I think it's going to be 2 terms. So I have x squared plus 2x plus 4. And that's divided by a x cubed. I don't know. I think that was supposed to be a squared. Yeah, I think that's supposed to be a squared. So if I factor out an x squared, factoring out an x squared, I'm going to be left with a x plus 2. And let me simplify that a little bit. Okay, now this can be confusing. So just remember that this can be rewritten as a x cubed minus 2 cubed. So hopefully when you see it in that relationship, you can see that that relates to, again, the difference of 2 cubes. So that's going to be factored into x minus 2, and then we'll go through that quadratic there. So therefore, this simplifies into, I'm going to have to write this small, x minus 2 times x squared, and then the product of, so that's going to be plus 2 times x, so it's plus 2x plus 4, which is 2 squared. And then that's all going to be over, this is a difference of 2 squares, so that's going to be x minus 2 times x plus 2. A lot of things going on here. So what I'm going to do now is, that was a what, a 4? Yeah. No, that's a 2. You factor out, oh, I'm sorry. You factor out an x, yeah, that's a 4. Okay, factor out an x here. Good. So now let's go ahead and flip and reciprocate everything. And I can't factor anything else out of there, actually. So I didn't really think I actually helped myself out. I thought I was going to factor this down, but I couldn't. So let's go ahead and flip and reciprocate. So I'll have x times x squared plus 2x plus 4 all over x squared times x plus 2. And that's going to be divided by, I'm sorry, not divided. We're changing this to a product, right? Times, now we're flipping these. So this is going to be an x minus 2 times an x plus 2 all over a x minus 2 times a x squared plus 2x plus 4. And now it comes into the simplifying party. So what can we simplify out? What are the expressions that are the same? Well, I see an x plus 2, I see an x plus 2. I see an x minus 2, I see an x minus 2. I see an x squared plus 2x plus 4, I see an x squared plus 2x plus 4. And therefore, I have an x over x squared. So before I simplify that, I'm going to say x over x squared. And then we just have to remember our rules of exponents. That is the same thing as x to the first minus 2, which is the same thing as x to the negative first, which is the same thing as 1 over x, which is my final answer. So I forgot to write in those equal signs there. So therefore, my final answer here is going to be 1 over x. Whew, pretty fun. But just remember, guys, the main thing I want you guys to take away from this is obviously multiplying. Don't get common denominators. A lot of people forget about that and they want to get common denominators. You're just multiplying straight across. Division, you're flipping and reciprocating, but there's a reason to it, okay? There's a reason why we are changing this to a multiplication problem and why we're multiplying by the reciprocal. That's to get the denominator equal to 1 here. And then also, not less least, before you apply any operations, simplify. Get everything factored out, all right? And then once you've multiplied, then go ahead and work to simplify a little bit further. So I hope that helps. Now we get into the really fun ones of simplifying rational or complex fractions.